Soldateschi. He is a developer, support engineer from the United States. He creates the Vergona event-based cloud scaling software. Well done.
This is me. This is Simone. I work as a software engineer, then as a systems engineer. Now, I work as a developer support engineer, which is much like a DevOps. It's much like a DevOps role. I'm a task automation enthusiast, and I really do love doing outdoor activities. As you see, feel free to just send me a message about Twitter or LinkedIn. So, well, Rackspace, they are a company based in San Antonio. They wanted to be a hosted company, and they started an amazing project, which is OpenStack. OpenStack is an extremely interesting way of managing cloud infrastructures. Rackspace is a co-founder with NASA, and they want to be recognized as one of the world's great service companies. So, what we are going to do now is to start talking about Python SDK and cloud components. The very first thing that you might want to do is to create a Python virtual environment on your laptop, say Python RU. And then, if you want to manage OpenStack components, chances are that you want to install Pyrax, which is an SDK. It's just a zip package that you can easily install on your laptop. For reference, just point your browser to that URL, and there are plenty of snippets of code ready to be used in your software. So, you can clone the repository that I set up for this event and just authenticate against an OpenStack auth component, just exporting three variables, OS auth user, API key, which is much like a password, and you need to specify a region should you need to manage cloud infrastructures across multiple regions. So let's export, define and export those environment variables, and what you get if you run the snippet of code that I set up is that you are able to authenticate against an OpenStack environment. And you can see that because you receive a valid token, the green line. You can use that token instead of your password API key, which is extremely secret, and the validity of that token is limited to just 24 hours. So with Pyrax, I said that you will be able to manage all OpenStack components, and there are really many components: cloud server, databases, load balancers, DNS, and whatever comes to your mind. With OpenStack, you can manage infrastructure as a service. So you would abstract hardware components, you place that OpenStack layer in between, and you would be able to spin up, to create a load balancer device, databases, much like as you would do with when you install a software. For our purposes, we just need to install, to use three components out of all of them, which are servers, monitoring, and photoscape, obviously. So So let's start discussing about autoscaling. Have you ever used any autoscale technology so far, even with competitors? Any of you? Okay, wait. So what is scaling? Traditionally, when you need more power, what you do is just buy more RAM, add CPU cores to your servers, and then from a 2 gig RAM, 2 cores server, you end up with an 8 gigabytes RAM and 8 cores. This is a brute force approach, which is not very good. Obviously, you are doing it wrong. What is autoscaling? So, say that you forecast, you know that at a certain point in time, maybe in January, you need to have 40 servers in order to serve traffic. So, in January, you are going to sell something, and you will generate a bunch of traffic. From the very beginning of your project, you need to provision 40 servers, even if you don't use them. And the gray area represents wasted money, which is extremely bad. So, say that somehow you are able to marry those two lines, the blue one, which is the traffic your infrastructure is experiencing, is serving, and the red line, bold line, which is the number of servers that you provision in your infrastructure. So you could follow the same trend as the traffic hitting your infrastructure. As you see, the gray area is reduced, it's extremely reduced, which in turns means that you're spending less money. And what you spend is what you need to serve traffic. This is the reason why you would use autoscaling. Traditionally, you would use dedicated server, I mean bare metal servers, and you end up naming server. I'm pretty sure many of you name their servers. I did in my previous company. Cloud servers, on the other hand, are livestock, which is you just use them as long as you need them. Okay, let's start discussing about traffic patterns. What is a traffic pattern? A traffic pattern is the way, the trend, traffic is hitting your infrastructure. So you could identify at the very least 4 different traffic patterns. One, namely on and off or Boolean, it means you need that many servers to serve traffic, and then you can spin them down. Think of servers needed for a bank office. They start working at 8 o'clock in the morning. At 5 o'clock, you could destroy those servers because we are not going to use them until next day. This is on and off. Or you could have a fast growth, maybe because you code something, you write /dot articles, and people are hitting and opening that page. Or variable, which means you know nothing about traffic hitting your servers. So you cannot forecast anything. Or consistent, you can see that there is a period where you can identify a trend. What are autoscaling methodologies? How can you handle those traffic patterns? There are 3 different autoscaling methodologies which you could identify at the very least. The first one, namely time-based, reactive, and predictive. The time-based is what I described earlier, talking about the bank office. So say that you have a load balancer, connected to that load balancer 2 servers. Then at 9 o'clock in the morning, on the 1st of November, you spin up an additional server. This is good for on and off. Or reactive, so you have a load balancer, 2 servers running at 60% CPU load, then traffic increases, then you see now the load on average is 80%, so it's above a certain threshold. You need to do something, you deploy an additional server. So now the overall average load of the entire infrastructure is lowered. As soon as traffic decreases below a certain lower threshold, you will be able to spin that server down again. So you end up again with 2 servers. This is reactive scaling, and it's extremely good for fast growth and variable. Predictive is when you try somehow to do some capacity planning and you are able to provision servers on demand. So you forecast that traffic is going to increase by 30%, and by that time you provision a new server, which is very good for fast growth and variable. So let's recap just a little about the 2 main methodologies. Schedule-based, so you set in time 0 to spin up additional servers, and a T-final, where you end up spinning down those servers. Or the most interesting part, which is the event-based scaling, you see that graph. That graph shows, displays how traffic is hitting your infrastructure. You set a threshold, the horizontal line. As soon as traffic reaches that threshold, you need to do something. You need to provision at runtime new servers. So you need to scale up. When you scale up, additional servers are spun up. At this point, you start a timer which is called cooldown. A cooldown is something that it's not so, it's quite easy if you think that. So let's say that when you want to provision a new server on the cloud, it might take some time, maybe 1, 2, 3 minutes. Okay, let's say it takes 3 minutes. Within 3 minutes, you already triggered a spin-up policy to scale up by 1 server, but that server is not ready yet to go live. So your infrastructure is still going with 2 servers. There is no reason to spin up additional servers because 1 server is being provisioned right now. So cool down, wait just 2 minutes for that new server to be ready, and then listen again to scaling policies. It acts much like the pace car in a race. So it sets the right pace. Cool down just a little, and then I listen to you trigger new scaling policies. As soon as the cooldown period expires, you are able to scale down or scale up again. So let's see a few use cases. Say that you're running, maybe not because you are Python developers, but many people out there are using a PHP application, maybe a WordPress or Django or whatever application. It doesn't matter really now. We are just looking at the problem from the perspective of a DevOps or a systems engineer. So it's just a box running something. So let's say that you have 2 WordPress nodes behind the front end with balancer. You could add additional nodes to that cluster until you have enough nodes to serve traffic. You could do pretty much the same with other applications, much like Drupal, Magento, Django, as I mentioned, or whatever. It's not always possible to do that unless nodes share nothing and nodes are stateless. What does it mean? It means that you store nothing on nodes. At the very least, sessions. Sessions shouldn't be stored in the temp directory on a node. Instead, you should use a database, a memcache daemon, a NoSQL database, whatever. A third component which is able to be reached by any nodes within your infrastructure. Another interesting use case is the boss worker model. So you could have front-end web servers. Those front-end web servers are reachable by end user over the internet, and people, clients, do something on those front-end web servers. Those front-end web servers will serve end users, but do not compute anything. Instead, they just put messages on a message queue for workers to work. So, if you use a model, you could use the approach, the technique that we saw earlier, just set a high threshold and a lower threshold to trigger scale up or scale down policies for the boss. What about workers? Workers are supposed to work at full throttle all the time. So it's not possible to set a threshold and to scale up or down according to that threshold. Instead, you should use a message queue, and according to the length of that message queue, you need to spin up or down workers. Okay, let's see some auto-scaling tools. The first thing that you need to use to manage your infrastructure running autoscale is a configuration management system, namely Puppet, Chef, SaltStack, or Ansible. Anyone using a configuration management system? Okay, how many of you use Puppet, Chef, or SaltStack? Okay, and how many of you use Ansible? Okay, so they're almost on the same page. Great. I chose to use Ansible because it streamlines management of servers, because it's agentless, which means you install Ansible as just a pip package on your management server, which could be even your laptop, and then you're done. Nothing else to do. What about installing agent on managed hosts? There is no agent. It leverages SSH. SSH is already installed, I think, on every box you need to manage. So it's really easy to start playing with Ansible. Why would you use a configuration management system? When you start using a configuration management system, you need to figure in your mind what is the desired state of the system. So you could provision a server, attach block devices, create file systems, install packages, configure packages and deploy applications, and at the point your server is ready to go live. What you need to do is to write code, manifest recipes, or playbook in the Ansible universe, to tell the computer how to manage itself. So you just state that is the desired state of that system, you run Ansible, and you care about nothing. Just run that. So now we need to have a control load. What is a control load? If you study control systems, you already know this diagram, which is you have a reference, which is a signal entering your system. You have the output of your sensor measuring something in your infrastructure. Then you have a controller capable of controlling all the aspects of your system and the system itself. So, for our purposes, you have a monitoring system. Then you have the output of the monitoring system, which is the load of servers. And according to threshold that you configure, you can spin servers up and down. As soon as you do that, Autoscale will put a message on the cloud server's message queue saying, hey, cloud server, spin that many cloud servers up. And you end up with pristine new servers. Those servers are able to do nothing because they are blank, vanilla, blank servers. So you need to run your configuration management system against those pristine servers in order for them to go live. So if you think a little about it, you realize that we are missing a component, the controller. We have cloud monitoring to measure the state of your system. You have autoscale to manage that, but you need to control your system. How do you do that? You need to have a piece of software able to trigger autoscale policies and manage servers, leveraging the monitoring reports and stats. So, if you put all together, you get a software, namely Garçon, which is what I wrote to solve, to address this issue, which acts much like a glue between a monitoring system, which could be our cloud monitoring, Nagios, Net New Relic, or whatever, to trigger scaling policies. And you end up with new servers. Garçon is composed of two different daemons. One is cloud monitoring to autoscale daemon, which is able to fetch data and stats from your monitoring system and to trigger scaling policies. Then there is a second daemon, namely configuration management daemon, which constantly asks autoscale what are the servers participating in the scaling group. So as soon as new servers are spun up, configuration management daemon runs Ansible or the configuration management system of your choice against those new nodes. So configuration management daemon, just recap, run Ansible. Maybe you might want to clone a GitHub repository to deploy the latest version of your application. In that way, you would be able to upgrade application running on your infrastructure. And those servers will be able to go live. So this is the Garçon implementation of the control law, closed loop control law. Closed loop because there is a feedback, as you see, there is a feedback produced by the monitoring system. So you are developers, so you might be interested in what's happening behind the scene, I suppose. So at first, you need to fetch the current list of servers participating in the scaling group, querying the autoscale component of OpenStack, specifying just a scaling group ID. At this point, you need to iterate over that list of current servers, and for every single server, you need to do something. So the very first thing to do is ask, is that server active or not? Maybe it was just spun up and is being provisioned right now. So it's a build process, it's in building. So we're not able to manage that servers yet. Should you be able to manage that server, you could get a handle to server's metadata and take a look, inspect if that server is already configured or not. This is just an optimization because if you use a configuration management system, you are familiar with the concept, the idea of idempotency. So no matter how many times you run your configuration management system against a server, it won't do anything if it's already configured. So the cloud monitoring autoscale daemon supports many different providers. The Rackspace cloud monitoring, New Relic is in testing, and we are working on supporting message queue and Nagios before open sourcing it, because otherwise you would need to use Rackspace. Instead, we want you to use whatever you want. So as soon as the Nagios and New Relic plugins are are tested, it will be open sourced. What about the triggering scale up and down policies? The very first thing that you need to do is to compute the average load of your infrastructure, not just a single server, but the load of all servers. Compare that average load of systems against configured thresholds. Should that load be over higher than the higher threshold, you need to spin up to trigger a spin up policy, and the other way around, should it be below the lower threshold. As you see, the HTTP status code is always 202, which means that you get no information leaking because you don't really know if it happened or not. So those are anonymous URL. Anyone who knows that URL will be able to trigger scale up or down policies. So just to prevent information leakage, we just return 202 for security reasons. So now it's time to discuss about configuration management daemon, which is the second daemon able to run the Ansible. You just need to ensure that that server is connected, is ready. You need to get metadata, knows if that server is already configured or not. If it's already configured, you can skip it. If you get an exception, it means that there is no metadata, so again, it's not configured, and you just need to run Ansible against that. If you remember, we said that servers, cloud servers, are livestock. So you never ever need to SSH into your cloud servers. Instead, the configuration management system should. So that is why we reset every time the password, every time the configuration management system works. At this point, it fetches the list of playbooks that you provisioned that are supposed to be run against that managed server. You prepare your environment, and then you run Ansible to configure your managed nodes. The very last action that you need to do is to create checks within your monitoring environment in order for that to monitor new servers so that they can participate to the scaling group. As soon as you do that, you can set the server metadata to configure, and the server is ready to go live. So, just to recap, we discussed briefly about the SDK, the Pyrax, the OpenStack component, the auto-scaling patterns and traffic patterns, using management systems, and why you should use management systems to run auto-scaling infrastructure. How could you implement a closed-loop control law, and how you could put all things together with the software to manage your scaling infrastructure from scratch. And yeah, I think that's pretty much it. Just send me an email or message. We'll be happy to discuss whatever we do.
Thanks for the talk. The one question, I didn't see one particular use case of load changing. And this use case is, for example, when you have small steady growth and then the DOS happens. So basically right now, which scares me in cloud providers, they almost all basically, I don't know right now, and that's what I want to ask. They all just saying, okay, if you have the DOS, it's your own problem, deal with it. We can help you by banning some IP address. But that's actually is not always can help. So, what do you think about that? How we can deal in the cloud with that kind of attacks? Because that kind of attacks can just cost you a lot of money in the clouds, which you pay for traffic and so on. And what's your status in Rackspace?
Yeah. As I promised, I wanted to keep it short, so I reduce the number of slides. But we go further within that presentation. We could configure properly your cloud infrastructure to reach and to implement what you asked. I think that it might be worth for us to run maybe a live demo stressing servers, so we can handle a real running working infrastructure, and we could experiment that maybe. Anyway, just to respond to your question, you could use the web control panel, or even configure your infrastructure from the command line querying APIs, get, curl, whatever, to configure properly systems, infrastructure, the balancer, signing IP, these kind of things. Everything is doable from the command line leveraging APIs. Okay. Does that respond to your question?
Yeah.
Okay.
Just one small question more. Okay, we have this configuration, but what to do if we didn't anticipate that? Is there some kind of protection can be built in cloud providers? Like, can generally cloud providers somehow fight those I don't know, use cases?
So, in order to address that issue, I would suggest you to create not just one cloud infrastructure, but maybe it might be worth having multiple infrastructure running in different regions. So should something bad happen to one particular cloud infrastructure, you could still use and have the second or the disaster recovery cloud infrastructure. So you just need to redirect the DNS request to the still running infrastructure. There are plenty of online services which DNS provides you with to address that issue. So it's just a problem of global traffic managers and DNS.
More questions? Thank you, Simone.
Okay.